Alright, hi you guys, and today we'll be talking about the introduction to analytic geometry, and it's the beginning of the conics slash analytic geometry chapter. So this is going to be the study of coordinate geometry from an algebraic standpoint, okay? So you're going to need to remember some important formulas from back in geometry. Like for example, the distance formula and midpoint formula for both the coordinate plane and the number line, okay? Alright, so the distance formula and midpoint formula should be very familiar. A little bit of some people forget how to do the distance formula on a number line, and you just take the two numbers and you subtract them by doing the absolute value. Okay. Also, another thing you're going to need is slope, because slope, we're definitely going to be talking about it. Parallel slope is the same. Okay. Well, is equal. Let's say equal rather than the same. Okay, and perpendicular slope is the negative reciprocal of itself. Okay. All right, and so in other words, for example, if the slope of one of your lines is a divided by b, then the perpendicular line, now this is going to be kind of cool, I'm going to be able to do it. Let's do a capital T, and what we're going to do is we're going to take that T and turn it around. Okay, and that's the symbol for working with perpendicular. Okay, that is perpendicular to negative b divided by a. Okay. Alright, now let's go remind ourselves of some rules and stuff, and this is what you're going to need to do to be able to prove this, and I'll talk about the diagonals after I'm done talking about the main things. Okay, parallelograms have opposite sides that are congruent and parallel, so you'll need to test both the distance formula and the slope formula to get there. Okay. Rhombi are parallelograms, so you're going to have these two checkups up here that have all sides being congruent. So this is the new step you need to prove. All sides, not just opposite, just all sides. Okay, trapezoids have one pair of opposite sides being parallel. Trapezoids are not parallelograms, I just thought of the rule next and that's what came up. Okay, so just if you have a quadrilateral, first off it needs to be quadrilateral for all these, and one pair of opposite sides are parallel, then you're dealing with trapezoid. Now for an isosceles trapezoid, you need to know that they're trapezoids where the non-parallel sides are congruent. So that's the important part right there. Okay, kites have two pairs of consecutive sides that are congruent. Rectangles are parallelograms, so once again, a certain type of parallelogram. So you need to prove opposite sides are congruent and parallel. So rectangles are parallelograms that consecutive sides are perpendicular. So this is going to be a new one. Okay, so opposite sides are going to be parallel, but consecutive sides are perpendicular. Now squares are like the rectangles and rhombi had a baby. They are parallelograms that have all sides being congruent and consecutive sides being perpendicular. Okay, so that's pretty simple right there. Now triangles. Scalene triangles have all sides not being congruent. Pretty simple. Isosceles triangles have at least two sides being congruent. Now that leads into the next one, because an equilateral can be an isosceles, for argument's sake, because it has at least two sides being congruent. So that's one of the rules. Equilateral triangles have all sides being congruent. Now I know some of you guys are going, oh, what about the angles being 60 around? That is true, but we're using analytical geometry, and we're going to be analyzing this on the coordinate plane. So the only thing we need to prove is that all sides are congruent of this triangle. Okay? Now, a right triangle has one pair of sides being perpendicular, and special right triangles follow that special 1 to 1 to root 2 ratio and the 1 to root 3 to 2 ratio. Okay, so this would be an isosceles isosceles right triangle, and then this would be a 30, 60, 90 triangle. Okay, now circles, pretty simple. All points on the edge are equidistant from the center. So if you were to test any point on the circle and then test the distance with the center point, they would all be the same. Okay. Alright, so that's all the rules that you're going to need to know for these simple shapes. Remember, the more complex you get, as long as you focus on the distance formula, midpoint formula, and slope formulas to help yourself out when you're trying to understand this stuff, it'll make your job so much easier. Okay? Alright, that's it for our intro to analytic geometry. I'll talk to you later. Bye.